Welcome everybody to the fourth section of this course, where this time we are going to take a look at Siamese neural networks. We are first going to take a look at the Omniglot Dataset, which is a set with a lot of characters in there. I'm going to tell you what a Siamese neural network is. I'm going to teach you how you can train and evaluate such a network. I'm going to spend a whole video talking about different loss functions you can use for your Siamese neural network. And at the end, I want to do a special video where we are going to determine what factors influence how fast your neural network is and how fast it is training, etc. But first, I'm going to discuss the Omniglot dataset. We are first going to take a look at what the Omniglot dataset is. I'm going to show you where you can download the data, how you can load and represent the images, and how we can represent a training and a testing task. Now, in previous videos, we took a look at the MNIST dataset, which is a dataset with a lot of characters, but there are only 10 classes, the numbers 0 to 9. Now, the Omniglot dataset is kind of reverse. You still have grayscale images. They are all 105 by 105, so a bit bigger than the MNIST. Characters. But this time there are 1623 classes. So that's a big difference with the 10 classes we had with MNIST. And there are only 20 examples per class. So you can imagine that the normal way you approach such a problem with a neural network won't work in this case. And here on the right you see some examples from the Futurama alphabet. Now if we zoom into one character, here are 20 samples of this one character, a face with eyes. To make these images, they asked a lot of participants to draw the same character. To download this data, you can go to this GitHub repository, which you see here on the screen. You should download the Python part of the data, and you should place it in your datasets folder. So in this case, there is like a train set and a evaluation set, and they split the set in two. So you have about the same amount of characters to train on and the same amount of characters to test on. And after you unzipped it, it should look like this. So you got your datasets folder. In there you put the Omniglot folder, which has a Python subfolder and a images background and images evaluation folder. To load the data, we first have to think about what kind of task we want to do. And in this case, we're not going to try to recognize each character, but we're going to ask the computer the question, hey, are these two characters the same or not? So if they are the same, we give them a label of 0. So if you see two funny heads, then you give them the label 0. It's kind of a distance metric. And if they are different, we give them the label 1. So if you have a funny looking head and a squiggly square, then we give them the label 1. And during evaluation, we can ask what character is the same as this one to the computer. So we show a funny face, and then we show some kind of strange triangle thingy, a pyramid with a cloud above, I don't know what it is, a fish and a funny face, and then the computer should give the lowest score to the funny face. At least that's what we hope, because then we know that that character is the same as the original character we saw. So let's take a look at how we can load the data, and how we can determine the tasks, and how we can visualize the data. So now you open the section 4 Jupyter Notebook, where I typed a lot of stuff at the start, and I'm going to skip it in this video. So remember that if you click this link, you will be taken to the GitHub page where you can download the Omniglot datasets. Now I start with a lot of imports that we need for our program. And I will set the data path variable here to where I stored the digits. But be sure to make this hopefully the same if you downloaded the data and unzipped it at the same place as me. So datasets, Omniglot, Python, and that's it. To load the images, I have a lot of code here, and explaining the code isn't really the focus of this course, because explaining it would take time away from explaining neural networks to solve this. So just maybe read through it if you're interested in it. But basically it boils down to we check every folder which is a character set, and we check every character in that folder and load that into something. Now let me start by resetting the kernel. So I will load the training set, which is a set with a lot of characters which we will use to train the computer to see if two images are the same or not. And then we load an evaluation set, which is a completely new different set of characters, where we thus offer a new character to the computer and ask him to pick one of the same characters on the right. Depending on the speed of your hard disk, this can take a while. And we're done. So to represent and train a neural network with this, we are going to give the computer two lists with characters and one list with labels. And the label will be 0 if the characters are the same, and 1 if the characters are different. So what we will do is we just randomly pick some characters. We first pick some characters from the same class and give them the label 0, and then we will pick some characters from a different class and give them the label 1. So after we picked our labels, I will select either the same category or a new class and picking a random character from that category. And we also have the one-shot task, where you show a character to the computer and he will have to find the same matching character from the other characters. And for this task, I'm going to set the first character to be the same as the other class, and the other characters are always different. So this way, the first character should match to the character you gave it. And let's run this code just so we have these tasks. We're not going to use them in this video yet, but in the next video. And now that we loaded them, we can get a batch of training data, visualize the images, and show the label. So we have the getBatch function, where we pass the dataset that we have, and let's print what label we have. So in this case, the similarity, or maybe distance is more appropriate, is the targets. So let's take a look at what data we have. We have a not finished hashtag, and these images are the same. Another squiggle, and these images are the same. And if you scroll down, you'll see that here you got two distinct characters. This looks like something for blind people, and they are not the same, so they have a bigger distance from each other. Alright, so that's it for loading our data. We now downloaded the data, we created the tasks that we will use later, and we visualized some characters.